Thank you. Thank you for your time. I have been very inspired by all the presentations and conversations we had during the breaks, and I actually recognized that we had a Zoom meeting, and I was probably wearing pajamas on the bottom with you, Professor Marianne, with one of the meetings with Professor Ben Hardy as well. And I'm also inspired by friends and putting invisible things visible, like you said before, and that I think that's what also motivates me as well. Trying to apply the academic kind of research and put it into to demonstrate the real value of these models that we come up with in the academia. And so today, thanks to you both, that you've outlined the overview of the importance of AI and where it is at the moment. And I just want to give you two illustrative cases and be really specific in terms of the use case, I guess, to make it more concrete. So today's talk is about achieving AI-driven value creation. Does anyone own a piggy bank at home? Anyone? Yep, a few people. I think it's a great thing, especially for my youngest daughter. She's just turned 2 and she loves playing with coins and putting the coins into the little hole. But Raiz is essentially a digital piggy bank where it links your transaction account, your bank credit card or debit card to your investment account, and every time you spend money on a cup of coffee, it automatically rounds up to the nearest dollar, to $4, and invests that 50 cents into a portfolio of investment products to hopefully help you save and invest without even realizing it. And so we just recently launched a national advertising campaign, which I just want to play to you. It's only 30 seconds long, so don't worry if I can play it. I played it before. Oop. See, I can't believe how the things you test before and are not working. Because I didn't have access to internet. Sorry about that. It was supposed to be a really quick thing, but okay. Okay, we'll just skip that. So I just wanted to give you an overview of what the product, what the company is, and then introduce the type of work I've been doing, and then illustrate the cases. So I've been with Raiz since 2017, and I work with primary data and secondary data. And I generate the primary data by running surveys, running field experiments and lab experiments with student samples at university to try to understand the mechanism, and then we take that into a field setting, run those experiments, but also run secondary data analysis. I still rely on econometric models or traditional statistical models, but also apply machine learning or deep learning in different contexts to answer different questions to objectives, launching new products, testing marketing communication effectiveness, forecasting demand, making predictions of churn, and recommending the products and services. And since 2016, which is when we joined, it had about $43 million fund under management. But recently, we've hit that $1 billion funds under management. Recently, grown from 65,000 customers to over 600,000 active customers. So the point that I want to make is that we can use research and AI to drive growth, even for an SME. And machine learning or AI is just one of the toolkits that we use to drive that growth for the company. And just to let you know that I have worked at Raiz Invest until last week, and as introduced, that I'm a full-time lecturer at UTS now. So before I was invited to do this presentation from a SME's perspective, but now my position slightly changed since then. And so the two cases of achieving AI-driven value creation that we'll talk about. And so what kind of value do we want to create? And mostly we focus on two things: enhancing customer experience and then achieving higher firm revenue. And I'll illustrate one specific case of recommender system where we collaborated with Professor Lina Yao and Shai Zhang, one of our PhD students from UNSW. And then also call center analytics. And I collaborate with Professor from Columbia Business School and a PhD student there as well. So to talk about the the recommender system in the context of Raiz Rewards. So Raiz Rewards is sort of like a loyalty program or cashback rewards platform where if you purchase from any one of our listed partners, you get a percentage of the purchase price invested automatically into your investment account. And the number of partners that we have on our app has grown from 0 to 280 in about December 2018, and it's over 200 brands. So the challenge is with over 200 plus brands to choose from, which brands should Raiz recommend to whom? And so that was the challenge, and the objective was let's build a state-of-the-art recommender system that recommends brands and cash rewards to our customers based on their transactional data. And I guess the context is recommending the right product to the right customer at the right time is at the heart of marketing, satisfying the unique needs of each unique customer. And when we look at the literature on this recommender system, there are two approaches. The first is user-based collaborative filtering algorithm, where things like customers who have bought this product have also bought. So that's the user-based approach. And then the item-based approach is this product is most frequently purchased with. And so we combine these two approaches to build two sort of parallel neural networks, which the predictions from each are weighted and then summed up for final prediction. And we show that our model beats other traditionally established recommender systems, at least in this case. And with that, we run a field experiment. We tested this algorithm against a different one and other controls, and we basically ran the algorithms and saw that the algorithm that we developed increased the cash rewards that customers received by more than 40%. So in that little experiment, and so the outcomes that we saw were first increased savings for Raiz customers, improved relevance and customer experience because they were recommended more relevant products, and obviously a contribution to knowledge on recommender system. And our revenue has been keep on increasing in this area. We've improved 92% increase over the last year as well, and we try to scale this to all of our customers, not just on a kind of experimental setting. So we have seen the benefits of AI and new machine learning algorithm development in partnership with a team of academics and put it into real practice and demonstrate the value for the business. The second project that I'm working on is looking at the customer call center, which is an important area, but it's quite understudied in marketing. And we want to understand how the dynamics of sentiment, your positive or negative emotions during the call, and how that influences the customer satisfaction score that they give at the end of each call, but also customer retention or churn after 1 year. So the conversations that service agents are having now with their customers, how predictive are they in terms of predicting their customer satisfaction and customer churn? And so we have two cases called A and B. The blue line is the agent, and the darker blue line is the customer. And you can kind of map the evolution or the dynamics of emotional sentiment throughout the call, and depending on what different people say. And for each call, we are able to associate that with a customer satisfaction score. So the top one is 7 out of 9, the bottom one is 1 out of 9. And emotionality is a strongly predictive of customer behavior, as we all know. And the agents' word choices are also very influential in terms of predicting customer satisfaction. So that's why I think companies invest a lot of money perfecting their scripts. And so the question is, can speaker sentiment and the dynamics thereof tell us about customer satisfaction and retention? And so the overall, so I understand this is not an academic presentation, but just want to show you what it kind of looks like. So you can map the evolution of the sentiment throughout the call, and you can identify certain patterns of the evolution that are associated with higher customer satisfaction or lower customer satisfaction. And one thing that we noticed is that for calls that scored high satisfaction have more positive sentiment from the service agent both at the beginning of the call and at the end of the call, more than the calls that were rated with low satisfaction score. And the same thing can be used to predict customer churn as well. And so what we try to do in this project is kind of come up with prototypical patterns for different calls between service agents and customers, and then find out the components of these prototypical patterns to make better predictions about the customer satisfaction and customer churn. And so what we did is, say, for example, on the far left, you have agent and sentiment evolution. And this is a combination of different prototypical patterns that we identify. So, for example, that's a certain factor or pattern we call pleasantries. And then it's a combination of pleasantries, deterioration, and troubleshooting. So these three kind of factors are the prototypical patterns that we identify from our data. And some combination or mixture of these prototypical patterns make up this agent sentiment. So we try to understand the different factors.
Are you using words or tone of voice or what?
We're just focusing on words only. So the type of words that people use are associated with positive emotion, other words related to negative emotion. The extension of this research is also looking at the vocal characteristics in terms of the tone, the pitch, pace, and so on. So that's still work in progress. And so you can map different types of agent sentiment by a combination of different prototypical patterns. And so based on that analysis, we identify 4 different prototypical patterns for the agents and 4 different prototypical patterns for the customers. And we use a combination of these things to make some predictions in terms of their customer satisfaction and customer churn. And we find some interesting things like agent positivity is very predictive for customer satisfaction and customer churn, more than the sentiment of the customer. So and that also stresses the importance of the sentiment of the agents in managing customer satisfaction and customer churn over time. And the one prototypical pattern that was very influential in customer satisfaction is deterioration, which looks like the top right, deterioration. If the agents display that kind of pattern during the call, then it's very predictive of the customer having negative customer satisfaction score. And the customer's average sentiment throughout the call is predictive of the customer satisfaction, but not as much as the agent's overall sentiment. We identify improvement, which is C1. That pattern was highly predictive of the customer satisfaction. So this is, and the way we incorporate machine learning and AI is we identify using topic modeling different topics of what customers are talking about, and also we've done some work in terms of categorizing the reason for the call using machine learning. That's a combination of human coding and then use that as a training data to predict the reason for the call. So it's a combination of kind of AI models with I guess linear regression in this case. So just wanted to demonstrate some use cases of how we try to enhance customer experience and firm revenue using this AI-driven recommender system, and also how we can better manage our relationship with customers with AI being a diagnostic and predictive insights. And so this is a work in progress where we're trying to understand, depending on the patterns that customers show, what's the optimal response from the service agent to be able to minimize customer churn and to maximize customer satisfaction. But these are some of the projects that I worked on, and we can chat to collaborate further to achieve AI-driven value creation, co-creation, if there's any opportunity. So thank you for your time. Questions or?
Any questions?
Thanks.
So firstly, look, it's very impressive, and coming from operationalizing AI, I can see how hard it is, right? So a question around, so how do you really, because this is a complex piece of work, right? How do you operate? Do you have a stack which you have built, like pipelines and things like that, or how are you doing it? Just want to understand.
This is pure labor. I worked with one of, and as we were presenting the project that I worked on with one of the largest car manufacturers. And I was working on forecasting the demand and optimizing the ad spend across different vehicles. And just collecting the data into one place took weeks. And this is like the largest, one of the largest car manufacturers. And also another largest furniture manufacturing company in Australia. I was working with them, but because it takes them so, it's so difficult for them to even put all their data into one place, the project got nowhere. So that's the biggest, I guess, barrier in terms of actually working on AI to create value. And I really could really resonate with me. Even with at Raiz, just looking at marketing data, compiling all of the data from Facebook, Twitter, Instagram, YouTube, Google, all the customer acquisition data, and also the advertising spend data into one source is a pain in the ass. And if there's a solution that just log in all the details into a single platform, and I get all the customer acquisition and advertising spend data into one common place, would save us hours and hours of work. But it's so.
There's one I already showed you. And anyway, just a follow-up question, right? So the models which you showed, I think from a performance perspective, they were a lot better than the one. So is this open sourced? Is it available for others, or it's proprietary? Yeah.
It's not open source. We're working on the publication of that project, so it would be soon, or hopefully if it ever gets published. But yes, but definitely we're willing to collaborate and
because there are a lot of people who are trying to do the same thing. So
yeah.
Anyway, so thank you. Very impressive work. I'm very impressed. Yeah.
Thank you.
Thank you.
I'll conclude with a couple of comments. So one bit of information I wanted to share was that